This is Miss Steele's Precalculus class. We are reviewing for the Chapter 6 test. An example problem we have is the distance from the clock tower at UWL to the top of Granddad's Bluff is 5,300 feet. Important piece of information, so I'll underline it. If the angle of elevation from the base of the clock tower to the top of the bluff is 6.35 degrees, and from the base of the clock tower to the top of the flagpole is 7.05 degrees, what is the height of the flagpole? Like any word problem, we will start out by drawing a picture. So this point down here is the clock tower at UWL. I'll label it with a C. And if here's the ground, and if this point up here is the top of Granddad's Bluff, I'll label it with a B. And here's my 90-degree angle that the bluff makes with the ground. We know that the distance from the clock tower to the bottom of the bluff is 5,300 feet. Anytime we're dealing with distance, we're talking about straight line distances, not hypotenuses. It's the level ground. First says if the angle of elevation from the base of the clock tower to the top of the bluff is 6.35 degrees, that means that this angle is 6.35 degrees. And then from the base of the clock tower to the top of the flagpole is 7.05 degrees. That means that we will have a second triangle. So starting at the clock tower, the top of the flagpole, this entire angle measure is 7.05 degrees. I'll label this top point as with an F for flagpole. So now we need to label our unknowns. We can start out by labeling this entire distance. Let's label it H for height. We can label our short unknown distance as X, and the smallest one is Y, which the one we labeled for Y we don't necessarily need. So first, starting out with the blue triangle, since we have the angle 6.35 degrees, and we know we're dealing with the x, which is the opposite side length, and we know the adjacent side length, the trig function that uses opposite and adjacent is tangent. So we will say tangent of 6.35 degrees is equal to x, because x is our opposite side length, over adjacent, which is 5,300, multiplying by 5,300 on both sides. We're left with x equals 5,300 times tangent of 6.35 degrees. Making sure that your calculator is in the degree mode, you know that our x value ends up equaling 589.8 feet. Now dealing with the red triangle. So if we are dealing with the red triangle, we are going to, again, use tangent. Instead of having tangent of 6.35 degrees, we'll have tangent of 7.05 degrees. And that's equal to opposite over adjacent. The opposite side length is h, divided by 5,300 feet. Again, multiplying by 5,300 on both sides, we are left with h equals 5,300 times tangent of 7.05. And this ends up equaling 655.45 feet. Now looking back at our original picture, we have, so now we know the entire height of Granddad's Bluff is 655.45 feet, and we know that, that 655.45 feet is including the flagpole, and then we know that just the height of Granddad's Bluff is 589.8 99.8 feet. So to find just the height of the flagpole, we know h equals x plus y. So if we know h is 655.45 feet, that's equal to 589.8 feet plus y. We can just subtract over the 589.8, and we're left with y equals 65.65 feet. And whether you want to round to 1 or 2 decimal places, it is totally up to you. The next problem we're going to take a look at is a law of cosines problem. For this example, it says an 85-foot tower is located on the side of a bluff in La Crosse. The side of the bluff makes an angle of 21 degrees to the horizontal, and a wire is to be attached to the top of the tower and anchored at a point 140 feet downhill from the base of the tower. Our goal is to find the shortest length of wire needed. So we're trying to find the hypotenuse. So one piece of information we're given right away is the height of the tower. We know that the height of the tower is 85 feet, so go ahead and label that right away. We also know that the side of the bluff makes an angle of 21 degrees to the horizontal. This means that we will need to draw in a horizontal line, so a dotted horizontal line, and it says that the side of the bluff makes an angle of 21 degrees. That means this angle I outlined in red is this 21 degree angle. So now I'm going to fill in this triangle. Now we have this triangle we're working with in red. That's a 90 degree angle, or a 90 degree triangle. It's a right triangle. We know that the hypotenuse of this triangle is 140 feet. So it's 140 feet. Go ahead and label that. So now our goal is to find the hypotenuse of the wire, or the hypotenuse of the large triangle or the wire itself. To do so, we need to first find this missing angle that's right next to the tower. An easy way to do that is to first find the angle in the right triangle that we created. To find the measure of this angle, we will take 180 degrees, and we'll subtract off 90 degrees, and then subtract off 21 degrees, because a triangle must add up to 180 degrees, and this is 69 degrees. This angle is equal to 69 degrees. So now to find, we label this other angle theta. To find theta, we know theta is equal to 180 degrees minus 69 degrees, because those two are supplementary angles. 180 minus 69 is 111 degrees, so theta is equal to 111 degrees. To make this picture a little clearer, I will redraw a triangle to the right. So we know that this angle measures 111 degrees. Let's label we'll label it A, B, and C. So it's a little easier to keep track of. So the side length from A to C is 140 feet. And we know that the height of the tower is 85 feet. So now notice we know a side length, an angle length, and a side length. So we know side, angle, side. If we wanted to, we could definitely do law of cosines. It's important to understand that we are not able to use law of sines because we do not have enough information. So we will use law of cosines. The law of cosines is, if we're looking for the opposite of our angle C, we know C squared is equal to A squared plus B squared minus A times B times, minus 2 times A times B, minus 2 times A times B, times the cosine of 100, times the cosine of the measure of angle C. So just filling in the information we know. C squared is equal to A squared. A is equal to 85, so we're going to have 85 squared. Side length B is 140, so we're going to have plus 140 squared minus 2 times 85 times 140 times the cosine of 111 degrees. Again, making sure that your calculator is in the correct mode, so it must be in degree mode. We end up with C squared equals 35,354.1572 feet. When noticing on your quiz, there's a lot of people that did not get this as their C squared value, or that did not get a correct C squared value. It is very important to remember order of operations. If you were to type this into your calculator right now, the C squared equals, if you were to type 85 squared plus 140 squared minus 2 times 85 times 140 times cosine of 111, you will get the same answer I did. A lot of people try to multiply and add their numbers first. However, it's important to know that multiplying 2 times 85 times 140 times cosine of 111 must come before taking 85 squared plus 140 squared and subtracting off the 2 times 85 times 140. This is just going back to Algebra 1, even, just remembering order of operations, remembering PEMDAS, and so forth. So when we finally get our answer of C squared equals 35,354 with a decimal, we still have some work to do. Since we have C squared, we need to take the square root of both sides to eliminate that square root in the square. Then we are left with C equals 188.03 feet. So 188.03 feet is the smallest or the shortest length of wiring needed for the tower.